All right, guys, so we're going to go over the fifth set of problems that you were given. You have a problem number 5. All right, so let's look at number 1. Number 1 is the question about the Ford F-150 truck. So it says the Ford F-150 truck can travel 150 miles on 10 gallons of gas. How much gas is required to travel 750 miles? And I ask that you provide the work that you showed me how you got the answer. Okay, so for this one, I had several people who had confusion about how to solve this problem. But basically, this is a proportion problem. You have 150 miles per 10 gallons. So it's just like I could say that I travel 60 miles per hour. So in 1 hour, I would have traveled 60 miles. Okay? So they're proportional. It's a proportion. So if I travel 150 miles on 10 gallons of gas, how many gallons of gas will it take for me to travel 750 miles? All right, so I had a lot of people who gave me answers but did not show me how they got the answers. And when I went back and asked, how do you show me the answers? A lot of them couldn't really tell me how they got the answer, but I gave them credit for it. So let's go over it. Let's think about this rationally. If I can travel 150 miles on 10 gallons of gas, that actually means that I can travel 15 miles on 1 gallon of gas. So what we did was we reduced this to the bare minimum. On 1 gallon of gas, I can drive 15 miles. On 10 gallons of gas, I could drive 150 miles. I reduced it to 15 miles per gallon. On this side, I want to go 750 miles, but how many gallons does it take? Well, if it takes 1 gallon to go 15 miles, then how many times will 15 go into 750? So if I divide 750 by 15, my answer will be 50 gallons. Okay? So that's how I got my answer. Now, I've had other people who did it the long way. So we're going to still use the same setup, 150 miles per 10 gallons. And that's going to be equal to 750 miles on unknown amount of gas, or gallons of gas. So you're going to say, we're going to cross multiply. So we're saying that 150 times x is going to give us the product of 750 times 10. So I'm going to divide by 150 because I'm solving for x. And by doing that to that side, I'm going to also, what I do on one side, I also have to do to the other. So when I multiply 750 times 10, I'm going to get 7,500. And then when I divide this 150x by 150, x will be left on this side by itself because we're solving for x. And then we're going to divide 7,500 by 150. And by doing that, we have a result of 50. So that's how we got the answers. I showed you two ways of setting this problem up. Remember, this is an example of a proportion. Okay? All right, so question number two. Question number two and question number three are direct variation problems. So this problem states if y varies directly as x and x is 9 when y is 15, find y when x is 33. Now, I was nice enough to give you the equation for direct variation, which you should by now know the equation for direct variation. So, what is direct variation? Direct variation is just a relationship that is directly proportional. When y is this, x will be this. And there's a factor that will help you figure out that relationship, and that is the constant. So the k is the constant. So let me show you what I wrote down here. So for direct variation, k is your constant. The constant never changes. Now your y is going to change and your x is going to change because they are in they have a direct proportional relationship. But the k, which is the constant, it never changes. Okay. So here's the problem that we were presented. When x is 9, y is 15. So the first thing you do to solve this problem is you write your equation down. We have our y, which is equal to our constant, which is k, times our x, which is in our equation is 9. So we're going to fill in what we know. I'm going to fill in my x here. So y is equal to k times 9. And then I'm going to fill in my y. So y is 15. 9 is x. We do not know what k is, and we're going to solve for k. So by doing so, we are going to divide by 9, and that's going to leave our variable alone on this side. So by doing that, k, which is our variable, is equal to 15 over 9. Now what we're going to do is we're going to reduce. We're going to reduce this, okay? Reduce so we don't have to multiply as much. And when we reduce, then we're working with the constant 5 over 3. So 5/3. All right, so no, we're not finished with the problem because we're just getting started. We found our constant, so now we're going to go back and fill in the information that we need in order to find out what's going on with what's going to happen to y when x is 33. So now we're going to start again with our equation. Y is equal to k times x. It's our direct variation equation. We're going to fill in what we know. Right now, we do not know y because we need to find out what y is. But we know our x, and we also know our constant, which is k. We know that it is 5 over 3. So I'm filling in what I know. Y is going to be equal to 5 divided by 3 times 33. So for those of you who have a problem multiplying or cross multiplying, what I did was I wrote 33 as a fraction, meaning I wrote it over 1. It's still 33. I just wrote it over 1. So you can easily see that we're cross multiplying. So by doing that, I see that 3 can go into 33 because 33 is divisible by 3, and it is 3 will go into 33 11 times. So then I can multiply 5 times 11. Cross multiplied, 3 will go into 33 11 times. 5 times 11 is 53. So what is our y? Our y is 55. So when y is 55, our k is 33. So that is your answer. That's how you do question number 2, direct variation. Like I mentioned before, question number 3. Question number 3 is also a direct variation problem. And let me stroll up so you can see it. And it is, given the ordered pairs, for the ordered pair, 3, 9, write an equation of the direct variation. Write an equation of the direct variation. So I gave you direct variation, the equation for direct variation again. So what we're going to do is we're going to plug in what we know. So it says given the ordered pairs 3 and 9. So we know that our x is 3 and our y is 9. Do we know what our constant is? No, we don't. We need to find the constant. So what we're going to do is we're going to set up our equation again, our direct variation equation. We're going to plug in what we know. 9 is our y, 3 is our x, and there's our constant, so we're solving for k. When I multiply, when I put everything in, I have 3k, or k times 3, is going to be equal to 9. I want to know what k is, so I'm going to divide by 3. Divide by 3, so we're left with k by itself. I want k to be by itself. So divide by 3. What I do on one side, I must also do to the other. So I'm going to divide 9 by 3. And when I divide 9 by 3, my answer is 3. So the constant is k. Now, are we finished? No, because the question says write an equation of the direct variation given the ordered pairs 3 and 9. So now we're going to come to the side. We're going to write our direct variation equation again. We're going to plug in what we know to make sure it's correct. And yes, we do get the constant, which is 3. We get that. All right, so how do we write our equation for direct variation? When y is such a number, x is going to be such a number. And our constant is going to be 3. So y is equal to 3x. And that's our answer. That's how you do direct variation. Okay? All right. Our next question, number 4. Number 4 is the question using the Pythagorean theorem. One of my favorites. I love Pythagorean theorems problems. All right, it says use the Pythagorean theorem to find the missing links. And I gave you an illustration. I did not fill in all the details, but if you look carefully, you'll see that it is a right triangle. But I didn't give you the sides. So you would need to, you can solve the problem without drawing your triangle, but I always draw my information. If I'm given a triangle, I always draw it out. I draw it out so I can work it out as well. All right, so here's the information that was given. It says you have side A, which is 3.5 centimeters. You have side B, which is 5.2 centimeters. And our side C, we do not know what the length is. And we know that we need to find the missing length of side C, which is the hypotenuse. What do we know about the hypotenuse? All right, so there's a lot that we know from this. There's a lot of information whether you know it or not, from what we were given. So if you look carefully at my illustration down here, I drew my own version of my triangle, and I labeled my sides. I labeled side A and side B, and I know that side C is the hypotenuse. So side C is going to be the distance between, this is point A, and this is point B. So this is side B, this is side A, but this is point A right here. Okay, so this right here is the space between those sides. All right, so what I'm going to do is I'm going to write down my Pythagorean theorem. A squared plus b squared is equal to c squared. And I also like to write the converse. Basically, you write it in reverse. C squared is equal to a squared plus b squared, because basically we are solving for the converse. We're solving for c squared, which is the hypotenuse. Okay. All right. So once again, I have my equation. I'm going to fill in what I know. Side A is 3.5. Side B is 2.5, and we need to find C. So I'm plugging in everything, and don't forget that you have to square A. You have to square B. So when you square 3.5 centimeters, you will get the answer 12.25 centimeters squared. When you square 5.2 centimeters, you will get the answer 27.04 centimeters squared. And these two lengths, when you add them together, it will give you the length of side C. Okay, and it's squared. Adding these two together, my answer is 39.29 centimeters squared. Is that the answer? And the audience says no, because our problem says find C, not C squared. C. So in order to find C, we need to take the square root. So what is the square root of 39.29 centimeters squared? So what I do on one side, I must also do to the other. So taking the square root, I get the following answer. And it's actually going to be a lot longer than what I wrote down, but the square root is 6.26817. It goes on and on and on and on and on, which is C. Now, I can't leave it like this. I have to decide what my final answer will be. So looking back at the answers that were given, the lengths that were given, I see that this answer has 2 points beyond, or there's two spaces behind the decimal point here. And in the final, or the first set of numbers, there's one place after the decimal point. So since these two numbers are what our guideposts are, these two numbers, our final answer needs to have one space after the decimal point. So what I'm going to do here is my answer. I'm going to come back here, and since I want one space, 1 point, or one digit after my decimal point, I'm going to look at the second digit, which is 6. If the number is 5 or greater, then you round up. If it's 4 or less, you round down. So since this is 6, I'm going to round up. So rounding up, this is 2. I'm going to round up to 3. So my answer will be 6.3 centimeters. And that's how you do question number 4. Last but not least, for you have a problem number 5. We have question number 5, and it says, use the properties of exponents to rewrite the expression so that the variable appears only once. So we have 2y to the third power times negative y to the seventh power. So what would be our answer? Okay. All right, so let's go back. All right, so what is the rule about exponents? All right, so there is a rule about multiplying exponents, and it's called, of course, the exponent product rule. All right, so basically for this situation, when you are multiplying two powers that have the same base, you can add the exponents. Okay? So we have two powers. Boom, boom. Do they have the same base? Yes, yes. So we're going to multiply. I have 2, and I have, this is a negative, but it's understood. It's understood as negative 1. So 2 times negative 1 is going to give me the answer of negative 2. And here is y to the third power, and I have y to the seventh power. So according to our rule, they have the same exponents. I can add them. Same base, I can add the exponents. So I have 3 and I have 7. 3 plus 7 is 10. So my final answer is negative 2 y to the 10th power. All right. This was an explanation of you have a problem number 5. Thanks.